Hello friends, the moment you have been waiting for, a little bit more detail on the Zen 3 microarchitecture. I'm really excited about this, not only because I'm magically drawing in space, it's a secret how we're doing it. What's not a secret is Zen 3 has broken cover. It contains a large series of performance improvements over Zen 2. Some of them you can only talk about, but some of them we can actually draw. And that's what we're going to do. We're going to show you the major difference between Zen 2 and Zen 3 on a physical layout perspective. But to do that, we have to rewind the clock just a little bit back to the 3rd gen AMD Ryzen processor. And for example, I've drawn here an AMD Ryzen 7 3700X. It has one compute die with 8 cores, and it has one I/O die that handles PCI Express, SATA, USB. And all the 3rd gen Ryzen processors kind of look like this, with 1 or 2 dies. But have you thought a whole lot about how that compute die is actually laid out? It matters. So let's zoom in. That's what we're going to do. So we're going to draw an arrow over here, and we're going to blow it up into a larger size. And what you'll find in the middle is L3 cache. There's 32 megs, so we'll just put a little 32s. Hard to write small with a marker like this, but 32 megs of L3 cache, and then also 4 cores on each side. So you've got 32 megs of L3 cache and 8 total CPU cores. And that is how we are laid out today in a Zen 2 microprocessor. So let's put Zen 3 on the board, and it looks a little bit different. And this isn't exactly how the chip is laid out in real life, but it helps to draw it this way, just so you can see what's going on. So we're going to put L3 there again. So we've got also 32 megs of L3, just like Zen 2. But here is the big difference, how the cores are laid out. We've got still 8 cores, but they're all together. All 8 cores are in one single large block. And here's a major difference. If on this CPU with Zen 2, you want to talk to the other group of 4 cores, you have to leave the CPU through the I/O die and come back up, right? You have to do this. You have to go back and forth between the 4 cores. And the same is true with cache. In fact, we can show you the division just by drawing it. The chip is kind of cut in half. That CCD is somewhat cut in half. You've got 16 megs with 4 cores on one side and 16 megs with 4 cores on the other side. And this is really great for scalability because it allows AMD to bolt groups of 4 together to make much larger blocks. So that's how we got to 16 cores in socket AM4, or heck, 64 cores with Threadripper. The design is awesome for scalability. But when it comes to gaming performance, something we're continuing to focus on and really drive hard, and also single thread performance, making that fast individual CPU core for responsive computing, the design in Zen 3 really helps. Having all of those cores together eliminates some communication penalties of leaving one group to go to the other. It also has the practical effect of doubling the cache that every core has access to directly. So on Zen 2, each group of 4 has direct access to 16 megs, but on Zen 3, direct access to 32. So let's put it together. You've got all 8 cores that can all talk to one another directly. And you've got 32 megs of cache where all the cores can talk directly to that too. So that's a lot more synchronicity in the design, a lot lower latency in the design. And that is a design goal that games really, really love. I think you're going to be really impressed by the gaming performance that the Zen 3 architecture can turn out. Oftentimes, it's difficult to talk about architectural changes in a diagram. Some of them are a little new connection from point A to point B, and that doesn't show up well in a picture. But this one does. This is a major design change coming into Zen 3, bringing 8 cores and 32 megs of cache together in one large block. So one more thing, I want to connect it back to the CPU you may eventually buy, the Zen 3 base CPU. So what if we put this die in this design? Well, it would actually look exactly the same. It's the same layout on the chip, but instead of having to come down and back up for one half of the die to talk to the other, Now it's just a direct connection back and forth. And if you wanted to add a second die, like we do with the AMD Ryzen 9 3900X or 3950X, well, that's fairly straightforward as well. You would just put another die in the package. So it doesn't change the layout of the AMD Ryzen CPUs with Zen 3. It just changes how the cores are configured inside to improve communication, make them faster, and help gaming performance at the end of the day.